Hello, this is assignment 1 from Comp 2132. Here's my assignment. I'm Bruno Ortega. We're gonna walk through the whole assignment. I prefer to do very organized with the comment and the exercise. It's helped me in my code to be like more structured about my coding. So that's why I like from the Keras data set, I import the fashioned data here. I do the train images, test images. Here's when you import the images after we're gonna test it. And the load, we're gonna load the data inside of the database here in Colab. I want to add something here for understand. So the labels are essentially the answer key. So the computer used to learn to check is working. In this case, in this fashion, in the data set, train labels, you can see here, train labels right here. Train label is that's correct the answer for the 60,000 images in my training set. The purpose of this is during the feed comment, the model looks at the training images, and it looks at the train label to see if that's right. So with all information, each one say train labels, check if the information is correct. And how it works, if the model, for example, guess dress, but the label says pullover, the model adjusts its internal weights to be more accurate to the next time. So that's why we know this is the correct information. That's the definition of training of labels, but the test, we have the test labels. The definition is there is our correct answer for the 10,000 images in your testing set. The purpose is these are using during the evaluate function. For example, the final exam, the model is never allowed to see this label while studying training. We only show them at the very end to calculate the final occurrence and see how well the model performs on images and never seen before. So basically, now the explanation for we can use the train labels or taste labels as well, because we're gonna use this in the whole homework. When I come back here, okay, so if you see here the shape, that's why we put the shape here in the length. This confirms we have 60,000 images for training, and each image is exactly 28 x 28 pixels. Here, the length here, that's representing the length. That's the like short of type of coding you can use it. For number 4, we print the numerical labels 0 to 9. Computers don't say pull over, they see a category number, so we define the class names to the map those numbers back to the word. Okay. Exactly, that's here, each one. We start down. Display the digital content. It showed that images is just a grep of number where 0 is black and 255 is the bridges white. Okay, that's the whole information. Same here. The same I told you before, the class name, the train labels, and use a plot library to turn those numbers back into a picture so we can verify the labels match the item. For example, confirm label 2 is indeed a pullover. Okay, in this case, is a pullover right here. We go down. What is label index 5? Doesn't mean label 3. Label 5 is corresponding label 5. Yes. So basically, that's a demonstration. Here we put the code in the 6. That's the answer here. So basically, label index 5 is 2 corresponding to the pullover. So basically, identified the label index 5 is the correspondent for the pullover. Okay, that's how information works. Now we go down here. That's the 500 images testing. 9 here. That's the other example for the pullover. Now the test index 500. We put the pullover again. And it's similar than previous before. Label index 500 is 2, corresponds to pullover again. Now we have the flating, wait. Yes, so this is the neutral network layers. We are using it a single row of data right here. That's where we have the 60,000 28x28 and the rest shapes the 28x28 square into a flat line of 784 pixels. Okay, we're going down. In this part right here, we divide all pixel values by 255 to scale them between 0 and 1. This is a skewing of numbers prevent the model math from getting too large and unstable. That's why we're doing here. But now we're gonna move to question number 14. Basically a sequential model, which means the data flow through the layers one after other in order. Okay, that's only like the label we put for everything get in order. 15 and 16, these two right here. At the density, okay, right here is the full connect high layers. Okay, we have the high layers, we have the regular layers. Here with the dense coding, everything is connect. And the ReLU, right here is activation function is used here to help the model learn complex uh, patterns by ignoring negative values. Okay. Wait, I think we see here, yes. Right here. The ReLU right here. The 16, the same thing, activation ReLU, you can see right here. Okay, the 17, it adds the final layer with 10 neurons, one for each cloning type. Okay, and similar than here, down square category, okay. And the 19 one is use softmax. Okay, we use softmax here too. The softmax on the last layer, this turn the model raw scores into probabilities. For example, the 90% chance this is a back, or 80% chance this is a pullover. Okay, so the highest percent becomes the final guess. Okay, that's how the softmax works. I'll explain this one. 21. Good. So the 21 right here is a compiler. Compiler sets the strategy. Okay, Adam and RM Sprum are optimizers. The brains, that's the name we can call it, does decide how to update the model weight to reduce errors. Okay, so we have this here. That's how we reduce the errors. For example, reduce the errors to say the percentage wrong. Example I told you before about softmax. Now we use the RMS SORP where we can reduce that errors as well. And also it converts for the 20 here as well. Converts integer labels into one hot vectors. This is required because categorical cross entropy needs to compare the probability list to a target list. Okay, so this is a category list and we compare to the target list because the target is test and the category is training labels. Okay, now we go to the 22, so fit command. This is the actual training process where the model looks at the images 10 times epoch to find parameters. Okay, so in this case, if you can see, we have the epoch here. That's the parameters. Here, that's the part we have option A, option B. I do both. Okay. And now we're almost done here. So we have the evaluation. The model of test images use the test images which the model has never seen to get final honest accurate score. So this is the score. Basically, we can get 313. So final test accuracy is 0.8878. Thank you for watching.